was Lambda Edge, and just some use cases of for it that might be useful or might be applicable for what we do at Wealth Wizards. So I'll talk you through what I know, what I've tried, and see how we get on. So to start with, right, we can host websites in AWS without servers, so we don't have to pay to run something just to serve up some traffic and just let AWS handle that side of things. And we can do this quite simply with S3 set up as a website with some public assets and index pages in there. And we can front that with CloudFront, which is a content delivery network or CDN. And there's and then you can point your website, your domain at it, and you can serve up pages. There's, so quite simply, if I was to show you this page, this is my S3 bucket. In here, there's various things deployed. Don't worry about the actual content, but I can browse to the S3 bucket through what they call a website URL for the bucket, and actually just see my fantastic Hello World application there. So that index page corresponds to the index page in there.
On ops, Dave.
Pardon?
You're wasted on platform. We need to get you into the UI.
Yeah, I know, it's a good UI. Putting CloudFront in front of it gives you a couple of ones. The one big advantage is you can do custom domains with HTTPS, which you can't do with S3 on its own, but it also pushes content into caches around the edge locations on the internet. So when a user goes to it, they pull from the nearest edge cache rather than going to the origin S3 every time, which in theory should be quicker. That's not our biggest benefit, really, to be honest. And you can, in fact, turn the caching right down to nothing, so you're always pulling from S3. And then CloudFront gives you various other benefits, which I'm not going to go into full detail, other than Lambda Edge, which is the bit I want to talk to today. So you all heard of AWS Lambda. It's just a way of running a function in the cloud without having to worry about compute. What you can do is deploy it against a CloudFront distribution, and that gets executed at one of 4 times within a user's request, which this diagram hopefully explains. So you can either execute the Lambda when the viewer makes a request to CloudFront or responds to the end user, or you can do request or response from the origin server. So the origin server in my previous diagram was S3, but in fact it could be anything really. And that Lambda can then manipulate the request and responses and a few other things as part of that execution. So I'm going to start with a hopefully really straightforward example. So this is done as a viewer response. So whenever a response comes out of CloudFront back to the user's browser, it'll decorate that response with a load of headers, and these are standard security headers that we typically add anyway. And in the cube world, this is done by our Nginx ingress. So you can see strict transport security, X-frame options, so on and so forth, and these can be whatever you want. And then cores, which is everyone's favorite headers. This can be done a bit more cleverly. So in this example, I'm checking for the request origin header and using that to populate the response. Obviously, in real world, would actually check what that origin was and just only return it if it's an acceptable one from our point of view. So in our world, it would be something like wealthwizards.io. And I can show you this executing. I have a little curl request here. Very simple curl. If you can see it at the bottom, it's CloudFront, and I'm actually setting the origin header in order to make sure that I get my cores headers back, X-frame options, all the other security headers. So this is done dynamically at the point the request is returned from CloudFront. So we can stick CloudFront in front of almost any service. So in this diagram, I'm just showing you a couple of examples. So I had CloudFront on S3, but we could actually do it. And my example was an API, and that API could actually be API gateway. It could be AppSync, or we could even go back to our Cube ELBs And the benefit kind of doing that and having CloudFront in the front is that we can do any of these Lambda Edge kind of manipulations across the board. Having looked into API gateway to try and add some of these security headers, it looks like we'd have to do it on every single API definition, which means it's going to be in the application code effectively, which firstly, we don't want platformy things in our application code. We want to save all that juicy stuff for the value business logic. Secondly, it's really easy to forget to add stuff, and then we pick it up on one of our pen testing or security scans, and have to go and fight, chase these things rather than it just being there out the box. The other thing I was going to say, actually, API Gateway, we're currently using it. It has two deployment types. One is regional and one is Edge. What the difference is that Edge is basically a regional API Gateway that has CloudFront in front of it. So by doing it ourselves, we actually get more control over CloudFront and what it does, how much it caches, and adding some of these Lambda Edge functions. So we're not adding more complexity, we're just adding additional. So I'm just kind of looking at ways of using Lambda Edge to handle some of our serverless APIs. And I'm kind of proposing that we should put CloudFront in front of our different APIs in order to kind of manage some of these bits and pieces. So that's just quite a simple example of decorating the API responses.
Dave, can we ask questions along, or do you want that in the end?
What I was going to say is, depending on how timing goes, although I'm not doing too badly,
you carry on.
I was going to hang on at the end and have a longer discussion for anyone that wants to.
Cool.
Cool. So the other case of using Lambda Edge I'm kind of playing around with is the idea of hosting websites. So in the original example, I had an S3 bucket, and I could just keep replacing the content in there, so replacing the index page with a new version of that, and it will get served up immediately, assuming caching control headers and stuff like that. But actually what we do with all our other services and our UIs where we host them on Kubernetes is we package them up and we release a version, and then we enable that version when we're ready. I was looking at whether we could do something similar with this, where we deploy a new version of a website and then have them running in parallel, so we can test the new version while the old one is the one that's being served up by default. And then when we're ready and happy, that we could switch over to enable the new version rather than it being coupled to the deployment of it at the time. And with our services, having this kind of mechanism, we can roll back quickly if there's a problem. The slight caveat to that, which is something we do with our existing CDN setup, is having assets available throughout the process. So even if we've changed the index page, if someone's browser is still caching an old one, it can still access the assets for that old version, so we don't get broken deployment, broken users experience at deployment times. And then also the last bit is trying to use the same code base for each environment, so we don't have to have different packages or different deployments of our websites at deployment time. And when I say websites, I'm kind of talking about our UIs, our front ends, not just a static website. So in theory, something like FactFind UI could kind of be deployed in this way. So this is kind of a diagram showing that. So I've still got my S3 bucket here, but this time I've got all my deployed websites within version folders. And then we've got for example, green, blue, and red environments here. So when I go into green, it hits a CloudFront distribution with a Lambda Edge functions. And what this one does is manipulate the path in S3 that I'm talking to be the version that's currently deployed in that environment. So it would then return the index page for 1, 0, and 2 in this example. And then same with blue, and then for example, red. We haven't deployed 102 yet because we're still testing it. So 101's made available. But actually, I've had the ability to add a version parameter to say, actually, I know you're red and you're not really running 101. You are running 101, but let me have a look at 102 so I can have a little preview of this. And so it then returns to 102. And the code for this is here. So I set, I keep forgetting in PowerPoint, you can't highlight stuff with your mouse. Your default version in this example is 106, and then the handler is basically looking at the request, getting the version parameter if it exists, and setting that as the origin custom path. So that's the path in S3. This is the request to S3, request to the origin. And then if it's not set, it just pushes you down to the default version and then calls back. And the one note I've got at the top is, although that's hard coded in this example, the documentation says about going and pulling it from either the parameter store or Dynamo or something else with a bit of caching going on in order to make that more dynamic rather than having to redeploy the Lambda each time. And I'll give you an example of that before I go too far. So you noticed in my S3 bucket, I had 3 different versions deployed, 106, 108, and 109. If I go, we've done that one, haven't we? If I just go to my distribution, that is an example of the default. So this is going to be 106 because that's what the Lambda's returning. And in fact, if I show you my network traffic, you'll see that the requests to the assets is looking for the 106 version there. And if I was to go and add the version parameter, it gives you a slightly different body. And if you look at the assets, it's pulling back the 109 assets. So if you imagine that I had another CloudFront distribution, which represented our production rather than our test environment, then that could be on a different version. That would be what we pull back by default. Hopefully that makes sense so far.
This is awesome, Dave.
Thank you. So the last piece of the puzzle, so I talked earlier about wanting to serve up exactly the same HTML or and assets from the S3 bucket. So in my 109 area, I have just one index HTML. And my hope is that we can keep all these things the same for our green, blue, and red environments. But that does leave us with the question of how do we get them to talk to different APIs in different environments? How do we configure them effectively? And you can't really manipulate response bodies from Lambda Edge, but what you can do is have a Lambda Edge that just provides a static response for that request. So I've got a destination in my CloudFront distribution that looks for any request to config.js. It invokes a Lambda Edge and returns a static payload back for that. So which means that we can return something different for green, something different for blue, and something different for red, which would be the API, main API domain name that you want it to talk to for that environment. And this is the code, and it's even simpler than all the others because all I'm doing is setting a response, status and body, and that body is just a little bit of JavaScript that sets a value in the browser that we can then access from somewhere else, which is what my next page was going to show you. So I just, in my HTML page, I have the reference to that as a reference to a relative URL. Pulls back config.json, which sets the value of this API endpoint, and then I can invoke that API endpoint and populate the body of my an element in my HTML with a value, which I will demonstrate to you now. So I had this one here. This is one CloudFront distribution I've got. You can see it's doing a call to config.json, which returns a payload which talks to another CloudFront distribution. And that is basically returning that response body okay. Then I've got a different CloudFront distribution. I'm pointing both of these at the 109 version of the website because to prove it's consistent and to use the latest code. And if I refresh that, it's also doing a request to config.js, and that contains the setting of this variable to this is a public API for just returning yes or no, and the payload is different that's displayed in the browser, so that's returning yes, and that's returning a response okay. So they're just different implementations of the config.js Lambda Edge payloads. So to kind of bring that together, this is the CloudFront config. I'm doing this all through the PowerPoint because it takes forever when I'm on a Zoom call to try and navigate through all these tabs and stuff in the AWS console. But we've got three behaviors defined in this CloudFront distribution. One is assets, which is the straight pass through, so we're always referencing the exact assets. One is, and that has no Lambda Edge definitions against it. Config.js is that static response that I was just showing you. So although it's got a backend defined, an origin defined, it never actually invokes it because all requests will come back with the static config JavaScript payload. And then the last one, default, which is the one that does the versioning of the index page. So your index will get pushed to the relevant version, and then all your assets are pulled down separately. And that is kind of how it works. And as I usually do, I completely ignore my notes on this, so I've probably not said everything I was going to say. And that's kind of it. So I'm just going to do one last slide before I kind of open up for the questions and discussion, which was to kind of pull it all together. So I showed you the bottom part of this diagram earlier. This is how I think we could put CloudFront in front of our APIs, and then we could have for each different domain name or different front end a CloudFront distribution that does the stuff around static content on S3. But again, I can't see any reason why we couldn't start putting this in front of Kubernetes in order to get coherent sort of domain names and also a transition path potentially, because we can, in theory, transition stuff fairly transparently. But that's all kind of unproven at the moment. That's work to be done. So I didn't go on as long as I thought I might. So that's pretty much it. So if anyone does have any questions or discussion points, comments, thoughts, whether you think it's a good idea, bad idea,